Hi everyone, welcome to Chemistry Alive Video Lessons Episode 2. Today we're going to explore more about atomic structure. Like the first episode, we have grouped atomic structure into the common type of questions that are taxable in examinations. So for this topic here, there are 5 common type of questions. The first, ionization energy. Second, electronic configurations. Third, trends of atoms and ions in a periodic table. Fourth, effects of electric field on ions. And lastly, subatomic particles. So for today, we'll just be focusing on electronic configurations. But first, let's recall what we have learned about writing electronic configurations in O level. Take for example, sodium. So to write the electronic configurations for sodium in O level, we were taught it to be written as 2, 8, 1. However, this way of writing electronic configurations is no longer adequate in A level. In A level, it is compulsory for us to illustrate how the electrons are distributed in a subshell and orbitals respectively. So there's usually 2 ways in which we can illustrate it, namely SPDF notations and electron inboxes representations. Be SPDF notations or electron inboxes representations, we have to know the sequence to which we fill the electrons into the orbitals. This energy diagram you see here is one that most schools have shown to help you to remember or to determine the order of filling the electrons to the orbitals itself. But do you know that we can actually decipher the sequence from the periodic table itself? But before we explore more about this, bear in mind that because the fact that vacant 4s orbitals has a lower energy compared to 3d, so when we fill electrons, we fill to the 4s orbital first before the 3d. Now, let me show you how you can write the SPDF notations with reference to the periodic table in just 3 simple and quick steps. The first, locate the positions of the element in the periodic table. Second, the order in which electrons are added to the orbitals will follow the order as we move through the periodic table in increasing proton number. But first, let me elaborate a little bit more about the periodic table. In O level, recall that we learned that elements are categorized into groups and period number. For example, elements in group 1 are so-called group 1 element because they have 1 valence electron, whereas elements in group 2, they are so-called group 2 element because they have 2 valence electron. Moving on to the period number. Hydrogen and helium has only 1 quantum shell, thus period 1. Lithium all the way to neon has 2 quantum shells, thus period 2. Sodium to argon has 3 quantum shells, thus period 3. So by knowing the number of quantum shells, the period number is known. In A level, we realize that the element can also be categorized according to the subshell in which the last electron is added to. Take for example, group 1 and group 2 are known as S block element because the last electron is added to the S subshell. Group 3 all the way to group 0, they are known as P block element because the last electron is added to the P subshell. Now let's focus on the middle block of element here. The last electrons is added to the D subshell. Thus, they are known as D block element. Now, let's put what we have just learned to figure out the electronic configurations of an element. Take for example, lithium. So step 1, locate lithium in the periodic table. So lithium itself is the first member of S block element and in period 2. Thus, its electronic configuration will end with 2s1. To figure out the complete electronic configurations, we just have to start from in front. So 1s2 and end off with 2s1. Next example, magnesium. Again, locate magnesium in a periodic table. So since magnesium is the second member of S block element in period 3, which implies its electronic configurations will end with 3s2. For its complete electron configurations, we just have to start from the front. So 1s2, 2s2, 2p6, and anode with 3s2. Next example, we have aluminium. Again, locate aluminium in the periodic table. So aluminium is the first member of the p block element and it belongs to period 3. Thus, its electron configurations will end with 3p1. So for its complete electron configurations, again we start from the front. 1s2, 2s2, 2p6, and anode with 3p1. So far, we have explored how to write electron configurations for elements having proton number less than 18. But what if the element have proton number more than 18 then? Let's say for example vanadium. Again, let's look at vanadium in the periodic table. So for vanadium itself, it belongs to the third element in D block. At the same time, it belongs to period 4. But bear in mind that for element having proton number more than 18, the electrons are added to the 4s orbital first before 3d. Thus, the complete electron configuration will thus be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d3. Remember to arrange the electron configurations in order of increasing quantum number. In the past 5 minutes, we have only explored about how to write electron configurations for atom. How about the electron configurations for ions? Our third step will discuss about this. So for anion, we will continue to expand the configurations with the additional electrons added. For cation, we'll remove the electrons from the rightmost subshell in the electron configuration. The catch will be you have to arrange the electron configurations in increasing quantum number before you remove the electrons. To write the configurations for an ion itself, be anion or cation, the tips will be to write the electron configurations for the atom first. Then for cation, do remember to arrange it according to increasing quantum number. Let's say for example here, vanadium with a charge of 2 plus here. So this is a cation here. So when you remove 2 electrons from the rightmost electron configurations. So we remove 2 electrons from 4s orbitals, and there you have the electron configurations for vanadium 2 plus. The electron configuration written in green is the correct configurations for vanadium 2 plus. Let's say and see what happens if we forgot to rearrange the configurations for the element in increasing quantum number, as seen here written in pink. So likewise, to form a charge of 2 plus, you need to remove 2 electrons from the furthest right side of the quantum of the electron configurations. So by removing 2 electrons from 3d3, we will now left with 3d1. So comparing, you can see that if we forgot to rearrange the quantum electron configuration increasing our quantum number, then we will not get the correct answer. In conclusions, to write the SPDA notations with reference to a periodic table, the 3 quick steps are: Step 1, locate the positions of elements in periodic table. Step 2, bear in mind that the order in which the electrons are added to the orbitals follow the order as we move through the periodic table in increasing proton number, meaning there's no need for you to draw out the energy diagram. Step 3, for writing electron configuration for ions. For anion, continue to expand the configurations with the additional electrons added. For cation, bear in mind, you have to arrange the original electron configurations of the atom in increasing quantum number before you remove the electrons from the rightmost subshell in the configurations. So for more tips on solving A-level chemistry questions, do visit me at www.edulivegroup.com.chemistry-alive/.